Hey guys, and welcome back to this class. In this lecture, we're going to continue our e-commerce example. We're going to look at logistic train.py. So after importing NumPy, you want to import matplotlib. And we're also going to need from scikit-learn the shuffle function. And of course, a way to get the data. Okay, once you have that, we're going to get binary data, and we're going to shuffle X and Y, just in case it was in order. Once you've done that, we want to create train and test sets. So you don't want to test on the same data that you trained on. Okay, and so we're going to withhold 100 samples to be our test set. Once you have that, we're going to randomly initialize the weights again. Okay, and then we're going to write our sigmoid. We're going to write our forward function. Just x times w plus b. And we're going to write a function to get our classification rate. That takes y and p, returns the mean of y equals p. And so that you've seen before. This you haven't. So this is the cross entropy. So this is going to take in the targets and p of y, which really means p of y given x. This is going to return the negative of the mean of t times np.log p of y plus 1 minus the targets times np.log 1 minus p of y. So that's just the direct definition. Okay, and now we're going to enter our main training loop. So we're going to keep an array of our training costs and our test costs. And I'm going to set my learning rate to be 0.001. We're going to go for 10,000 epochs. And in each iteration of this loop, we're going to calculate py train, which is just passing x train through the logistic, and py test, which is passing an x test into the logistic. We're going to calculate the training cost, which is the cross entropy of y train and py train. We're going to get the test cost, which is the cross entropy of y test and py test. We're going to then append those to our list of costs. So this one gets c train and this one gets c test. Okay, and now we're ready to do gradient descent. So this is going to be the vectorized version of these equations. So it's the learning rate times x train transpose dot py train minus y train, the targets. And the bias will be learning rate times py train minus y train, and you take the sum. And if I mod 1000 equals 0, so that we only print every 1000 steps, we're going to print the training cost and the test cost. Finally, once all that is done, we can print out the final train classification rate, which is going to be the classification rate of y train and then we round py train. So those would be the predictions. Do the same thing for the test classification rate. That takes in y test and round of py test. Okay, and then another interesting thing we can do is we can plot the costs. So we want our legend so we know which one's which. So we plot train costs, and the label will be train cost. The second one we'll plot test costs, and the label will be test cost. And we call plt.legend, pass in legend1 and legend2, and then we show this. Okay, so let's run this file. Alright, so the train and test costs end up about the same. And our final classification rate is 96% for the train set, 92% for the test set.